All right, for those of you that missed class today, just a quick rundown of the notes that we took and kind of what you missed so you can get the homework done and keep up with what we did. Today we're talking about graphing quadratic functions. A quadratic function, hopefully you remember a lot of things about functions back from 9th grade, but a quadratic function, what is different about that is you still have an input, just like things you've probably seen in the past are y equals 5x. This is a linear function. I plug numbers in for x, and I get an answer for y. It's kind of like a vending machine, right? You put something in for x, you get something out for y. We also write this as f of x equals 5x. That's just another way of saying the output is equal to 5 times the input. So what changes this year is we mainly are focusing on quadratic functions. And the biggest difference in a quadratic function than what you've seen is this right here, having x squared in the function. That causes it to do a lot of different things because I'll show you the graph in a few minutes, but different inputs, different x's can give us the same output. And here's what it looks like. A quadratic function looks like this. It looks like almost like a U. We call it a parabola. And it looks like this because this is the quadratic function y equals x squared. So when I plug in something for x and square it, I get my y value. So if I plug in 1 and I square it, I get 1. So I go over 1, up 1, and I get this point. But the reason we've got two sides to this graph is because if I plug in -1 for x, so instead of plugging in 1, if I plug in -1 and I square it, a negative times a negative is a positive. So even though I plugged in a different number, I also got 1 positive as my output. So my function, the graph of my function is symmetrical. It looks kind of like a U. And if I drew a line right here down the middle, one side is a reflection of the other side. And that's just because of the nature of that squared. It allows us to get two different answers for the same input. So the first thing that we're going to do is graphing these functions. And they look like, I gave you an example right here. Graph the function y equals 2x squared plus 8x minus 1. So I know this has some pieces of a linear function. It has an 8x, it has a 1, but that's not the only thing that it has. This right here, this x squared, makes it a quadratic function. And when we graph it, we're going to get something that looks similar to what I showed you. We're going to get a parabola. It might shift left or right, up, down. It might be skinny. It might be fat. It might flip upside down or point sideways. But I get a different version of the same basic shape. So here's the steps that you're going to go through. I wrote them out right here for you on your notes. I'm going to walk you through them on the calculator. So I'm going to leave my calculator screen up here so you can see what I'm actually pushing in order to do this. So the first thing that we need to do when we graph, and again, hopefully this is just a review for a lot of you, is we click on the y equals. And this lets us graph a function. So on one side of the equal sign, we have our y, just like in our example. This y sub 1 side, y sub 2, this just means I can graph more than one at the same time. And I'm going to because I want you to see how they compare. So I already graphed x squared. Now I want to graph the example. So I hit y equals, and then it says to make sure no plots are highlighted. Right now, my plot is highlighted, but if I go up to it, to this little equal sign, and I hit enter, that means it won't graph my original picture. So it wants me to make a new one. And all I do is I type in the rest of the function. So my function was 2, so I hit 2, and then x squared. In order to get x, I'm going to push this button right here, xt beta n. I'm going to push that button to get me an x. So 2x, and then I need to square it. And then I'm going to add 8x. So I hit 8 and then the x button again. and then I'm going to subtract 1. So all I do is type in the function just like it showed me on my example. Y equals 2x squared plus 8x minus 1. And I hit enter, and now I have this function plugged into the calculator. To see that function, I push the graph button, which is right here. So I hit graph and a window pops up and it gives me a picture of my function. It shows me the graph. It shows me what it looks like. And there's a couple of things I want you to notice. It looks similar to the original one that I showed you, but it's shifted over, it's shifted down. It looks a little bit skinnier, but it's still pointing up. It still looks like a U. So some things have changed. A lot of it's the same. A few recommendations. This zoom button right here. If I click zoom, and this is in your notes as well, zoom 6 right here, Z standard. If I choose that option, if I go down to Z6, that will usually, whoops, sorry, I got a little ahead of my buttons. If I hit enter on that, it usually will give me the graph that I want. What that basically does is it gives me 10 tick marks up, 10 to the right, 10 to the left, and 10 down. If I want to change that, if I want to see more than that, let's say that I want to see higher on the graph, I can click on window and I can change any of these I want. I can change my smallest x value to be smaller. So I can change that to be -20. Not -22. Let's just go -20. I can go down to my biggest x. I can change that to be +20. X scale means how much each little tick mark represents. Y minimum, that's my smallest y value, and I'm going to leave that at -10 because my graph stopped at the bottom. If I look at more picture down here, smaller than -10, it's not going to give me any more picture. And then my y max, I can set to whatever I want. I can set it to 100 if I want to. And when I hit enter, that saves my settings and I can go to graph. And now if you look at it, it's still the same picture. It just looks a little bit different. I've got 100 tick marks going up right here. I've got 20 going to the left. And that just kind of gives me some perspective. We're going to stick with zoom standard for now because it's going to give us the help that we need the most. It lets us kind of see, I can tell that right here I cross the y-axis at about -1, -2, -3, at about -4. At -4 over, I cross, I cross my x-axis. So another helpful tool right here is table. It's right up here above graph. If I hit second graph, it gives me a list of inputs and outputs. It tells me that if I put 0 in my function, I get the answer -1. If I put 1 in my function, I get the answer 9. If I get 2, my answer is 23. I can also change those. I can scroll up to see what happens if I get -1, -2, -3. And here's what I think is interesting about quadratic functions. If I plug in a 0, my output is -1. I get the same output if I plug in a -4. I also get -1. And that happens in every situation. If I plug in a 1, I get a 9. If I plug in a -5, I get a 9. So there's going to be 2 inputs for most of these outputs that match each other. Okay? So we're going to use this function, we're going to use this graph, and we're going to use this table to answer some questions. So if you go back to your notes, we'll skip here to the next page. One more thing really quick. If you do not have a TI-84 at home, this right here is one of the reasons I suggest you get one. We're going to be using it in class all the time, and then you go home and you can't do your homework as easily. If you don't have one and can't get one, if you go to this website right here, desmos.com, www.desmos.com, it gives you a really nice graphing calculator that is very similar to the TI-84. A lot of the buttons are the same. A lot of the things that you do use the same buttons. So for this class, I'm just going to show you how to use the TI-84. but know that you can use Desmos if you need to. So the first thing it wants us to do is use the table to find specific coordinates. So it wants us to use that table function to find where the function passes through the point that x is equal to 2, and we don't know what the y is. So I go back to my table, and I find where 2 is at, which is right here. And when x is equal to 2, y is equal to 23. So the nice thing about doing this on the calculator is I don't have to do any extra math. The calculator does a lot of it for, well, that's not true. I might have to do some, but the calculator does a lot of it for me. I know that at x equals 2, y equals 23. I can check any point I want. I can check what happens if x is equal to 25. What do I get? And what happens if x is equal to 7? What do I get? And I just go to the table and I scroll down until I find the number I'm looking for. I can scroll down. There's 5, 6, 7. So when x is equal to 7, y equals 153. So this is going to be 153. When x equals 25, I have a feeling my number is going to be pretty big. And I think, let's see if this still works. It used to work. I used to be able to type it in and hit enter, and it doesn't anymore. Sorry, you're going to have to scroll down until you get to 25. And we're not going to take the time to do that, but you can. You can scroll down as far as you want, find the answer that you're looking for. Okay? The second thing it wants us to find is the vertex. And remember, the vertex is a specific point on the graph. And it's one of the easiest points to see because the vertex is where the parabola changes direction. And what I mean by that is it's when the parabola stops going down and starts going up. It changes direction. So for this one, I want to go back to my graph. And I'm looking for where the picture stops going down and starts going up, which is right here. And it looks to me like that's, if I look at the picture at this lowest point right here before it changes, it looks like that's 1, 2, 3, 4, 5, 6, 7, 8. That looks like it's at about -9 down, and it looks like it's over 1, 2. So it looks like it's at the point. I go left -2 and I go down -9. That's where it appears to be. That's the way this picture is set up, that looks pretty accurate, but you can't always tell for sure. One of the ways that you can tell if you don't trust what you're looking at is if you click this trace button. Right now, if I just start moving the arrows, I get this little cursor on the screen that moves around. But that's going to take a while to get it exactly where I want it to get, because if you look at the units down here, it's not moving very far. But if I hit trace, it binds that to my function. And as I push over, it kind of follows my function. And usually, one of the points it stops at is my vertex. And if you notice right here, it starts going up. So I'm going down, down, and now all of a sudden I'm going back up again. So if I look closely at my numbers where that happens, I'm at -1.96969696. I'm almost at -2. And over here, I'm at -8.999. I'm almost at -9. And if I go over, those switch. Now I'm just a little bit above -2 and a little bit below -9. And so in between those 2 points is the point -2 and -9. So you can trace it to try and find the exact point. There's another feature called calculate. If I hit second and up here it says calculate, one of my options, if I scroll down, says minimum, and it will help me find the smallest point on my graph. So I hit enter and it gives me this cursor and it says left bound. What that means is I need to pick a point to the left of my lowest point. and I hit enter. Now it says right bound. So now I need to go to the right of my lowest point and put enter. And so it's showing me that my smallest point is in between here somewhere. And I can even make a guess and try to get as close as I can. And then when I hit enter again, it tells me that my minimum is negative 2.0000001 and negative 9. So I'm confident that my vertex, the smallest point, is negative 2, negative 9. Lots of different ways to do that. You can write those down. Use trace, use calculate minimum, or use your eyeballs to get it as accurate as you can. All right. Next thing it wants us to find. Remember that the two sides of a graph on opposite sides. So the two sides of the graph that are on opposite sides of what's called the axis of symmetry look like mirror images of each other. So copy that down and hit play when you're ready to go again. So it wants us to find the axis of symmetry, which means that the two sides of the graph that are on the opposite sides of the axis look like a mirror. All that means is if I were to draw a line on my picture, if I were to draw a line, where would that line need to be drawn so that one side was a mirror image of the other? Okay, where would that need to be drawn? And if I do that on this picture, this side of the graph looks the same as this side of the graph. So my line would go straight up and down like this. And then when I ask myself, which axis is that? Is that going left and right or up and down? If it's going left and right, that's our x-axis. Remember right here, this is our x-axis. But our line of symmetry goes up and down. And that's our y-axis. Okay, because it looks like the y-axis. It goes straight up and down. So on my answer, what is the axis of symmetry? I'm going to put it's the y-axis. That means it's symmetrical over the y-axis. It looks like a mirror on one side and the other of the y. Okay, next thing it wants, and if you want to put a little note here that you cut it in half so it looks like a mirror. Next thing it wants us to find is the Y-intercept. And remember, the Y-intercept is the point that the graph crosses, and here's where we need to be careful. It intercepts the y, so that's where it crosses the y-axis. It intercepts the y, so that's where it crosses the y-axis. But it crosses the y-axis when x is equal to 0. A lot of you want to say that the y-intercept is where y equals 0. If I look at my graph, this is the y-axis right here. And if I look at where I cross my y-axis, it happens right about at this point. And that point isn't to the right, it's not to the left. It's exactly on the y-axis, which means that my x is going to be 0. So you're looking to find the y-intercept, we want x to equal 0 because that's where it crosses. And when I graph this, that's really nice and easy to find because I just go to my table, second table, and I look for when does x equal 0. And to do that, I'm going to have to go up. Bear with me just a minute. Your calculator goes a little bit faster than my computer version of this. X equals 0 when y equals negative 1. And if I look at my graph, 0, negative 1, so here's my 0 and I go down 1, that looks accurate. That looks right. So my answer, my y-intercept, would be when x is 0, y is negative 1. Okay, so we use the table. Use the table to find y when x equals 0. Not hard to do at all. go to the table, find x equals 0, and that gives you y. The only hard part is remember that y-axis or y-intercept means x is 0. And it's the opposite. The next question says approximate that x intercepts. And that means that the x-intercept is where we cross the x-axis, but y is equal to 0. So on the picture, I'm looking for where I cross the x-axis. And remember, this is my x-axis. And I cross it in this point, and I actually cross it in 2 places. I cross the x-axis in 2 different places. And that at those places, y is equal to 0. The reason it says to approximate is because we haven't taught you how to go backwards. We've taught you how to find y when x is equal to 0. But when I look at my function, when I look at 2x squared plus 8x minus 1, I'm asking you, what do you put in for x so that y is equal to 0? And that's a lot harder to do. So the way that we do this is we use the picture to approximate as close as we can. Okay, so when I look at this, picture, I cross the x-axis at -1, -2, -3, at about -4, but a little bit bigger than -4. So one of my points is going to be -4-ish. Not exactly, but it's at about -4. Going to the right, it also crosses right here, which is just a little bit bigger than 0. It's not exactly 0. It's to the right a little bit. And so it doesn't cross right at 0. It crosses at, I'm going to say, maybe just 0.10. And maybe on -4, maybe we don't want to use -4. Maybe we want to approximate a little bit closer. But those are pretty good estimates as to where it crosses. And the nice thing is right here is going to be a 0, because we know y is equal to 0. So -4, 0 is about the approximate point. A little bit bigger than 0 to the right, and 0 is the other point that it crosses. You just kind of have to make your best guess. Okay? So these questions, if it tells you to use the graph or to use the calculator to graph it, go for it. In fact, all of these you're going to be able to use the calculator to graph it. But we're also going to teach you how to graph it by hand here in a few minutes. Last couple things that I need you to do as far as technology goes, these questions. What is the domain is another question you're going to get. And remember that the domain of a function are all the possible inputs. Domain of a function are all possible inputs or values of x. So the domain means what possible values can I plug in to get, what possible values of x are possible? What can I plug in for x? Technically, all the possible values of the independent variable is the mathy definition. But we just want to know what are all the possible x's that we could plug in. And looking at the picture, these are my x's going left and right. And in my picture, I keep going further and further and further and further to the right, and I keep going further and further and further to the left. That's going to go on forever. It's going to take a really long time, some really big y values, to get me clear over to the left. But no matter what x I put in, whether I put in -5 or 505, I get a value of y on my graph. So my domain is everything that's possible, and because x can be anything, I can plug anything I want in for x and get an answer for y. My domain is infinite. And we usually use an inequality, or we say something like it can be from -infinity up to infinity. Or we say it's, when it's anything, we don't need to use an inequality symbol. We can just use the infinity. Okay, it can be any small number, any big number, it doesn't matter. Now, range is a little bit different with quadratic functions. What is the range? The range of a function is all the possible outputs or values of y. So it's not all of the different things I can plug in, it's all the different things that come out. So technically, it's all the possible values of the dependent variable. Now, what that means by dependent is y, whatever I get for y depends on what I put in for x. Remember, my function, I put something in for x, and depending on what I put in, I get something out for y. Again, it's like a vending machine. X is the code that I put into the vending machine, and a different code spits out a different kind of candy bar. So my different x's spit out a different y. But when I look at my graph, one thing I want you to notice, and maybe I should, let's show you just really quick. If I look at my possible y values, let's go to negative 100. And then let's also go clear up to 100. And let's graph that again. So I changed my picture just a little bit. That's why my graph got really stretched out. But all the way up, my biggest point up here is 100. And I'm getting values of y. But look at down here. Look at all this space down here where there's no value. This is my lowest point right here. Everything underneath it is not part of the graph. So there's no y values down here, which means no matter what I put in as an x, my outputs can only get so small. And if I look at my value right here, my lowest point, let's go back to our standard window. The lowest point I could get on my picture is this point right here before it started going up. And that value for y was negative 9, right? The lowest I can get is negative 1, 2, 3, 4, 5, 6, 7, 8, 9. That's the lowest possible value for y. So my range is any number greater than or equal to negative 9. That's going to be my output. That's my range. The other way that we usually would write this, the smallest number I can get is negative 9. And that can go all the way up to infinity. This means the same thing as y is greater than or equal to negative 9. It goes all the way from negative 9 up to infinity. So I put this bracket to say it can be negative 9 and it can go all the way up to infinity. This one, we would just have the round brackets. We wouldn't have the square ones because negative, infinity, and infinity aren't a specific number. Okay, so for the range, you look at what's the smallest or the biggest thing that y can be, and y goes up forever as x goes up forever. But no matter how big or small I get x, my y never gets smaller than negative 9. So that's my range. Okay, this looks like homework problem number 1. So what I want you to do really quick before you move on is try homework problem number 1 and then come back and if you get it right, come back and move on with the video. If you get it wrong, maybe rewatch part of the video, try and find what you did wrong. Okay, next thing that we need to talk about is what happens if we don't have technology? What if I have to graph without my fancy calculator? So the general form of a quadratic function is y equals some number times x squared plus some number times x plus some number, an a, a b, and a c. Those are coefficients. The x squared, the x, and the no x's right here don't change. Okay, so for example, right here, f of x, remember that just means the same thing as y. F of x equals negative x squared. Now be really careful on this one because that negative is in front of the x squared. So you plug something in for x, square it, and whatever answer you get has a negative in front of it. So negative x squared plus 4x plus 3. I make a big deal about that because this is a very different problem than if I were to put negative x in parentheses and then square it. This is very different, and that's the one that we want to focus on. Okay, so step one, if I have to graph this by hand, the first thing that I'm going to do is I'm going to make a table of a few x and y values, probably about 3. I'm going to make a table of x and y values. The first one I'm going to use is the vertex. So I made a little table right here. Here's my x's, here's my y's, and I want to pick a couple numbers for x and see what I get for y. I don't want to randomly pick them because depending on the x's I pick, I might not get a good overview of my entire graph. So I want to start with a very specific x, and that is the vertex. And we can find that by hand. Since we're doing this by hand, I've got to find the vertex by hand. And the way I do that is the x coordinate of my vertex, the x value that's going to go right here. So my vertex is going to be something x, something y. The x value is going to equal negative b divided by 2 times a. That's going to be what I use for x, for my vertex. So I take this right here and I just plug in numbers from the problem. Negative b goes on top. B is what's ever in front of the x. So when I look at my example, 4x. So there's a positive 4 in front of my x, but I don't want positive 4. It tells me that I want negative whatever b is. And since b is positive, negative 4 is the negative. On the bottom, I put 2 times a. 2 goes on bottom. A is this number out in front. And right here, my a is negative 1. That negative sign is my a, so it's just negative 1. So this becomes negative 4. 2 times negative 1 is negative 2. Negative 4 divided by negative 2, that's just positive 2. So what that tells me is my vertex, x, the x value of my vertex is going to be 2. That's going to be the lowest point. So to find the y, I have to plug my x in to my function. So I'm going to take 2 and I'm going to plug it into my function right here. Because I know that f of x equals negative, and instead of x squared, I'm going to put 2 squared, plus 4, and instead of x, I'm going to put a 2, plus 3. And now I solve. 2 squared is 4, negative 2 squared is negative 4, plus 4 times 2, that's plus 8, plus 3. Negative 4 plus 8 is positive 4, plus 3 more is positive 7. So my y value at the lowest point is going to be 2. My x, 7. My x is going to be 2. My y at that point is going to be 7. All right, next step. We are going to decide what other values I want to use, okay? I want to decide, well, what else can I plug in? And to give me a pretty good idea of what my picture is going to look like. The way I would pick my next 2 numbers is I would pick one number above and one number below. So you start with the vertex, 2 and 7. The next thing I'm going to do, I'm going to choose x values around the vertex. And like I said, I like to pick one above the vertex and one below the vertex. So I've got to plug one in above, one in below. So when I look back at my table, my x is 2. So one bigger than 2 is 3. So I want to find it for 3. And one smaller than 2 is the value 1. So I am going to plug these in for my X, and I'm going to see what I get for my Y. So if I plug in a 3 for X right here, my Y is going to equal negative 3 squared plus 4 times 3 plus 3, which becomes negative 9 plus 12 plus 3, which becomes these two make a positive 3, plus another 3 gives me 6. So when X is equal to 3, Y is going to be equal to 6. And I do the same thing with the 1. If X is equal to 1, Y equals negative 1 squared plus 4 times 1 plus 3. 1 squared is 1, so negative 1. Plus 4 times 1 is 4. Plus 3. Negative 1 plus 4, that's 3. 3 plus 3 is 6. So my Y value for both of those points is 6. And I plug those in to my graph. So that's our next step. I've got my Y values. I've got 2 and 7. I have 3 and 6, and I have 1 and 6. Those are my different points that are on the graph. I plugged them into the function. I know they're on the graph. We're going to plot those. There was a little note right here. Remember that the parabola is symmetrical, and that's why I'm using those numbers above and below the vertex, because I know on one side it's going to go up in one direction, on the other side it's going to go up the other. So step 2 is just to plot the points, and I'm going to connect them. So on my graph, I go 2, 7. So that means I go over 1, 2, and I go up 1, 2, 3, 4, 5, 6, 7. There's one of my points. 3, 6 is another point. 1, 2, 3, and I'm going to go up to 6. Another point is 1, 6. So I go over 1, up 1, 2, 3, 4, 5, 6. So my picture looks something like that, and then I can connect them. This is going to come down. This is going to come down. And it's going to look something like that. Maybe not perfect, maybe not exactly like that, but it's going to look something like that picture. Okay? Now the fun part. When we're graphing by hand, we have to plug in extra values for X sometimes. So if it wants us to know the function passes through the point when X equals 4, what does Y equal? I don't have a table to do that for me, so I have to plug that in to my function. So Y equals negative 4 squared plus 4 times 4 plus 4. So negative 16 plus 4 just equals 4. So when X is equal to 4, Y is equal to 4. So on my graph, if I go back to it, if I go over 1, 2, 3, 4, 1, 2, 3, 4, I should be going through that point right there. And I'm kind of close. It also wants to know where is the vertex. The nice thing is we already found the vertex when we plotted the graph. We found that the vertex is 2, 7. So to answer that question, I just plug in 2, 7. I already found it. Okay, what is the axis of symmetry? If I look at my picture, where does it look like it's being reflected? Is it being reflected up and down or left and right? And clearly, it's being reflected left and right this way. So it's being reflected over this line that goes up and down. So my axis of symmetry is the y-axis, which is always going to be true. It's always going to be true as long as the parabola is pointed up or down. If the parabola points left or right, that changes. But if the parabola opens, if the opening of the parabola is up or down, then you know that it's reflects over the y-axis. Next step here, it wants us to find the y-intercept. What is the y-intercept? So instead of just being able to use the table, we have to plug in 0 for x. Remember, the y-intercept means that x equals 0, and we're looking for what y equals. So I plug in x equals 0. So y is equal to negative 0 squared. Remember, I'm just plugging these into the function negative x squared plus 4x plus 3. So negative 0 squared plus 4 times 0 plus 3. Well, this is just 0. This multiplies to 0, so all I'm left with is 3. So my y-intercept is going to be x is 0, y is a positive 3. Uh-oh. Where'd we go? Did I use the wrong function? And none of you told me? Right here, I added 4 instead of adding 3. That's not supposed to happen. That's supposed to be a 3. That's supposed to be a 3, which means this is a 3, which means the function passes through 4, 3. See what happens when you record a video and no one's there to tell you you wrote a 4 instead of a 3. Thanks a lot not being here. Nonetheless, we have what we want. The y-intercept is 0, 3. Use the graph to estimate the x-intercepts. Again, we kind of just have to look at the picture and see where does it look like it's crossing the x-axis. Where does it look like y is equal to 0? And looking at my picture, y looks like it equals 0, 1, 2, 3, 4, a little bit bigger than 4, maybe at like 4.5. Oops, 4.5. And it also looks like it's crossing 0 down here, maybe at about -1. Maybe at about -1. So my x-intercepts are approximately, they're at about -1, 0, and 0.5, 4.5, 0. That's about where they are. So my x-intercepts are about -1 and 4.5, approximately. I'm not going to say they're equal to those points. I'm going to say they're about those points. Okay, domain and range. What is the domain? If I look at my graph again, it looks like x can be anything. It's going to go to the left as far as it can. It's going to end up going to the right. I can plug any number in I want for x. So my domain for x is -infinity all the way up to infinity. We'll have some examples later on where the domain isn't infinite. But for right now, the domain's usually going to be infinite. It can be any small number, any big number. That's what goes into... those are the inputs. Those are the x values that are possible. What is the range? I need to look at my picture. And for y, going up and down, these arrows, this graph is going to go down forever. That means my y values are going to get smaller and smaller and more negative. But as I'm going up my graph, it stops right here at the vertex and goes back down. So that point right there is the biggest y value that I can get. And that was point at y equals 7. So for my range, the lowest that y can go is infinite. That graph is going to go down forever. But the biggest y value I can get is exactly 7. So I'm going to put a bracket there because it can be 7. But that's the biggest that it can be. So this one, for the domain, it's usually going to be infinite. We'll have a few examples when it's not. The range, you've got to use the graph and find the high or low point. And that's it. Okay, so this looks just like homework number 5. So what I want you to do is pause the video, go to homework number 5, and answer that question. See if you can get it correct. As long as you can do it good, you're ready to move on. All right. Now, as far as the rest of what we're doing goes, this last step is just really quick. And in fact, I'm not even going to walk you through it. I'm just going to quickly show you an example. What it wants us to do is find a quadratic function that fits 3 points. So here's your example right here. It gives me 3 different points, 1, 9, 2, 4, 4, -30. It gives me those 2 points, and it wants to know what is the function. So what is f of x? What does the function look like? Y equals 7x plus 2, 9 squared plus 24w. What does it look like with these 3 points being on the parabola? Okay, and what we do is on the TI-84, here's the steps that you're going to go through. Again, I'll walk you through those really quick. If you don't have a TI-84, you can go to this website, and it'll give you an easy tool to do the same stuff. You're going to plug in the numbers, click on the button, and it'll give you the function, okay? Basically, what we're doing is we're going to create a regression. This tells us what is the line of best fit. Whoops. Line of best. Whoa, that got messy. Line of best fit. Or in our case, what's the parabola that fits these 3 points the best? Okay, so on your calculator, what you're going to do, it tells you step 1 is to hit stat. Stat is this button right here, S-T-A-T. That's how you know it's stat. If I click on that button and then I hit number 1, I want to edit. So stat 1 is the first step. You want to make sure that these lists are cleared out. So you go to the top and hit clear if there's something in there and hit enter. And then I go to the top of L1 and hit clear and enter because I don't want anything in those lists. What it wants me to do is under list 1, I'm going to put the X values, and under list 2, I'm going to put the Y values. It's very careful. It's very important, that you are careful. So in list 1, my first X value is 1. The Y value that goes with the 1 goes across from the 1. And we'll get to that in just a minute. So my first X value is 1. I know that's the first X value because I'm looking at this right here. Here's an X, here's an X, here's an X. So I plug those in. 1 is my first one. 2 is my next X value. 4 is my last X value. Okay. Now I plug in the Y values in this list, but they have to match these. The 1 goes with the 9. The 2 goes with the 4. The 4 goes with the -30. I can't just put them wherever I want. The 1 has to go with the same Y value, which was 9. The 2 has to go with the same Y value, which was 4. And then if I plug in 4, the value that goes with that one was -30. And I hit enter. Okay, so list, edit, put your X's here, put your Y's here, make sure they match. Okay, now if I go to stat again, and I'm going to push if you look at the top, it has edit, calculate, and tests. We don't want to edit anymore. We already edited our list. What I want to do is use my lists to calculate something. And as I scroll down here, I can calculate a lot of different things. A linear regression, which we can't do because we don't have a linear function. We have a quadratic function, which is right here. Number 5, quadratic function. So I'm going to select that I want it to calculate the quadratic function, the quadratic regression that matches those numbers. Yours might say what list do you want to use for X's, what list do you want to use for Y's. If you have one of the yellow TI-84s, a lot of times it just automatically uses those lists. It doesn't give you an option. So yes, I want list 1. Yes, I want list 2. And I just keep hitting enter till I get down to calculate. When I do that, it tells me my quadratic regression, my quadratic regression is A is equal to -4, B is equal to 7, C is equal to 6. All I have to do is plug those into this formula. So I go Y equals, instead of A, I put -4. X squared stays the same. And then I put a plus. B times X. B is 7, so plus 7X. And C is 6, so I add 6. And that is the quadratic function that best fits those 3 points. That would be your answer. All right? Okay, as far as your homework goes, whoops, let me close out of here. I think you have one more homework problem that looks really similar to these. Homework number 10 looks like what we just did. So if you want to pause the video really quick, go to homework number 10 and try it. Make sure that you can do that correctly. Once you're able to do that, go on ahead and finish the rest of the homework. Remember that this homework is due on Wednesday for all of you. Okay, it needs to be done on Wednesday for you to get full credit for it. So you're finishing homework number 6. You've already done 3 of the problems. Now you're going to finish it up by Wednesday so you can get full credit. Good luck. Come see me if you have any questions on Tuesday.